When we're declaring an enumeration type, it is possible to define a set of default values for its cases. The default values are also known as raw values. For a given enumeration type, the raw values must have the same data type. This data type is declared at the time of enumeration type declaration, and the raw value data type can be selected from strings, characters, integer types, and floating point types. But other data types cannot be used with raw values. Also, the raw values within an enumeration type must be unique. And finally, we can't use raw values together with associated values. Here is an example of how raw values can be set. The syntax is similar to what we've seen before. The only difference is that we mention the raw value type in front of the enum type name, and those two are separated by a colon. Then within the body of the enum, we mention the actual raw values. In this example, we're saying that pen has a raw value of 10, book has a raw value of 20, and stapler has a raw value of 30. The raw values of the individual cases of an enum type can be extracted using an arrangement like this, where we are saying that we are dealing with an enum type called desk object, and the case of interest is pen, and we would like to extract the raw value of pen. So this structure would return a value which is going to be equal to the raw value of pen, which is 10, and 10 is assigned to x. Alternatively, we can declare a parameter such as y and assign to it the value pen using this arrangement. Then we can again use the keyword raw value in a structure like this, the name of our parameter followed by a dot, and then the keyword raw value. This thing then would return the raw value of y, which was set to be equal to pen. So the raw value of pen is 10, and that value is returned to z. When we are dealing with raw values of type integer or string, the raw values do not have to be assigned explicitly by us. If those are not assigned explicitly, Swift will assign them implicitly. If the raw values are of type string, the missing raw values are determined by Swift according to the name of the enumeration cases. If the raw values are of type integer, a missing raw value is obtained by incrementing the raw value of the previous case. If the first case of an enum has no explicit raw value, and if the raw values are of type integer, the first raw value is set to be equal to 0. Here are some examples. In this case, we have an enum called SumEnum. The raw values are all of type integer. So the first case here does not have an explicit raw value. So according to the rules I just mentioned, a raw value of 0 is assigned to x0. The third case here does not have a raw value. The case before it has a raw value of 20. So the raw value of x2 here is determined by incrementing 20 by 1. So the raw value of x2 is going to be 21. The raw values in this second example are of type string. The first case here is not assigned a raw value, so Swift determines that the raw value here is going to be the same as the value of this case, which is S0. And the third case, S2, also does not have an explicit raw value, so it is assigned a raw value which is equal to S2. Again, S2 is the value of this case. We have already seen how a parameter can be declared to be of an enumeration type, and we've already seen how we can assign a value to such a parameter. If an enumeration type has raw values, we could use these raw values to make an assignment to a parameter. This is done through an initializer function whose name is the same as the enumeration type. This initializer function has a single input parameter, and the argument label for this parameter is raw value. The initializer function returns an optional which is of enumeration type of interest. This means that if we don't use a valid raw value, the initializer would return nil. Let's have a look at an example for this. Here we have some enum declared like so. It has raw values of type integer, and the raw values can be determined according to information here. Now, how are we going to use the initializer can be seen from the examples below. First of all, we are declaring a variable q and assigning it the return value of this arrangement. What we see here is actually the initializer. This is the name of the initializer, the parentheses, and within the parentheses we are having the input argument. As I mentioned earlier, the argument label is raw value, and this is the actual value which is used as input parameter. So notice that the name of the initializer is the same as the name of our enum type. And then what this expression says is that we are looking for the case within this enum which has a raw value of 20. By looking into this, we see x1 is the value. So that is the value which is actually returned by some enum, the initializer, some enum. And that value is assigned to q. Again, as I mentioned earlier, what is returned here is an optional, and the type of that optional is the same as some enum. So q has the value which is equal to x1, and its type is optional some enum. This first statement here is the case of a declaration and initial assignment. We could actually reassign values to q, again using some enum like so. So for this second line of code here, we are saying that q is equal to some enum for a raw value of 22. So what is returned again by some enum here is the case of some enum which has a raw value of 22. That case is x3, which is assigned to q. Don't forget that when you're dealing with optionals, if we want to use the actual value of that optional in the remaining part of the code, we have to unwrap it. So the same thing applies to q here. Finally, let's have a look at the case where we use a raw value which is not valid. In this case 40. 40 is not a raw value which is part of this arrangement. So as a result, what is returned by some enum here is nil, indicating that there is no case of some enum here which corresponds to a raw value of 40. One other thing to mention here in terms of integer raw values is that we should not set explicit raw values such that when the implicit raw values are defined, there is a clash of values. For instance, if we set x3 to be equal to 21, that's the explicit setting of raw value, x2 will be calculated by Swift to be equal to 21 as well. And then because the raw values are unique, that will cause an error, because we will have a situation here where both x2 and x3 have the same raw value. So it is very important that when we set the explicit raw values, we bear that in mind and make sure we set those values such that when the implicit values are calculated, there is no clash between the different raw values. When we declare an enumeration type which has associated values, the associated values themselves could be of type which is the same as of our enumeration type. This is the case of recursive enumerations. When we are using recursive enumerations, we indicate it by using the keyword indirect. Here is an example of such a case where we have an enum called some enum. The first two cases are just regular cases, but the last two cases are the cases where the associated values include some values of type some enum. Some enum, if you notice, is the same as the type of our enum here. So we are using the same type as our enum type within the same enum definition. So this is the case of recursion. When we do use recursion, we need to indicate it by using the keyword indirect. When using indirect like this, it means that before every case of our enum, we have to use the keyword indirect if we are using recursion. We can use a shorthand, and instead of using indirect multiple number of times, we can mention the keyword indirect only once before keyword enum, and then eliminate all the usage of the keyword indirect within our definition. This brings us to the end of our tutorial on Swift's enumerations.